All right, let's get started. Thank you all for showing up today. Once again, it's time for Chem 170 Organic Chemistry with your host, me, Dr. White. Now, a couple important things. First of all, as I said last Wednesday, and I put out in an email, at least I'm pretty sure I did, I'll check after class, and I'll say it, put out another one. Test number 1, which was originally scheduled for this Wednesday, will be postponed by 1 week, and it'll be 1 week from this Wednesday, whatever the date is, 1 week from this Wednesday. I don't have it in front of me, but it will be postponed by 1 week. And that's that. Also, I'm not sure if I said I'd do it today, but I think it's better I postpone it till Wednesday. On Wednesday, I will go through the alkenes, alkynes problem set. Also, don't forget, your lab is due, the one we did last Wednesday, this Wednesday, when you upload it as a single PDF or Word document page. I charge extra for kit and item. By the way, teach them this, 4 bonds to carbon. But anyways, don't forget to upload your lab. That's due Wednesday. Now, on a personal note, I should tell you, ECC this summer and now have made all faculty who haven't taught online classes before take these 2 classes through a company called QM Matters. And over the summer, there was one that was synchronous. And this week, I'm finishing one that's asynchronous. And it taught me a lot of things. One of the most important things I didn't realize is that when we're in face-to-face in campus, because of my mandatory attendance, if I made an announcement, everybody would hear it. Or if I said something important. Well, online, that's not true. Because A, you may have missed, for whatever reason, our lecture today, especially some of you who work in places such as pharmacies, nursing homes, or hospitals. And if some of your colleagues get the virus, you've got to cover for them. And I've had that happen with my students, so understand that. But even though I post the video, you might fast forward through it. So what that really means is I have to do better communications with you. So what I will be doing is sending out more emails, any kind of important information. And I'll probably do it twice. They may say, oh, come on, he's doing another email on the same thing. But because I don't know about you, but my mailbox can get really full and I can miss an email. And this way, I usually don't, but who knows? This way, if you miss one, you won't hopefully miss the second one. So I'll be doing that from here on out. The other thing that I also realized from the class I'm finishing up now is one of the things that we don't have, seriously, we don't have, that when we're face-to-face we do, is socialization between me and you, and also between your colleagues. And in the coming week or two, I'm going to think of ways, and if you can think of ways, let me know, how I can foster socialization so you can get to know me better. Well, you get to know me because I'm on your screen, but I get to know you better, and you get to socialize and get to know some of your colleagues as an important part of being in class, and it's not happening online as much as I'd like to see it. Now, two other things before we get started. Don't forget, how many bonds to carbon? 4, 4, 4. Actually, 4 and 4. And I can do it even with my eyes closed. You should know there's 4 bonds to carbon. Next thing I'd ask you, if you passed a gas station or saw a candle or Vaseline or cooked with natural gas or your barbecue, did you think of alkanes? Remember, when you're leaving my class, organic chemistry is all around you. And don't be afraid to think about it. It won't hurt. All right, let's get to work. Last week I was talking about aromatic compounds. Did any of you happen to smell some cinnamon or nutmeg or cloves or vanillin and think about, ooh, those are organic compounds I'm smelling? You will in a couple, I'll work on you. Dr. White doesn't give up. Remember, organic chemistry is all around you in the spices and herbs you use, in the vegetables and fruits you'll learn more about this semester, and even in the foods you buy. Organic molecules are in all those. By the way, you'll learn later in the semester, but I'll give it away now. You know where there's very, very, very sophisticated organic chemistry? Cosmetics and nail polish. That's some high level organic chemistry. The highest paid chemists I know of in the chemical industry are perfume chemists. In fact, years ago, I tried to apply. Nope, you don't have the right experience and you smoke. We don't want you. At that time, I smoked. But those are the highest paid chemists of all organic chemists, those who work for the perfume companies. But let's get on to chapter 4. We're talking about aromatic compounds. Anybody remember Kekula and the snake dream? I won't ask that on a test. And I showed you my stamps, and I finally got my hands on this stamp. I actually now have 2 of them, which made me very happy to this day. Now, I showed you this is a structure for benzene, and on a test, you can either write it this way, which I don't like. I think this is cooler, but either way would be right. And another, what we call resonance form, where you're moving the electrons, would be this form. Any one of these 3 forms would be right for benzene. And benzene is both the Iupac and the common name for this compound. I don't know why it did that. If you were to write this on a test, that's wrong, because that's really cyclohexane. And remember, for benzene, you need the bonds inside, 3 conjugated bonds, double bonds, single, double, single, double, single, double. Conjugated means alternating single and double bonds, or you can show what's called the localized pi cloud way of using this ring here. Either way, if you draw it like this, that's wrong, because that's cyclohexane. And that's the mistake I see on test 1. I'm telling you that so you don't make it on test 1. Now, when there's a methyl group on benzene, we call that toluene. And I'm just covering styrene, won't be on the test. I showed you about ortho, para, and meta. Remember ortho? Oh, let me change pen colors. Ortho is 1,2 disubstituted benzene ring. Meta is a 1,3 disubstituted benzene ring. And para is a 1,4 disubstituted benzene ring. And when you have toluene, even though the methyl group is included in the word toluene, if I had another substituent on the ring, this methyl group would be considered 1 to 2, so you can have ortho something toluene meta or para something toluene. Now, we sort of ended up, and let's continue on, with new substituents you need to know. Therefore, quick commercial from Dr. White. Don't forget, everything you see on the screen is on D2L for you to download. Also, another quick commercial. Don't forget, on Monday and Wednesday nights in Zoom, a different URL. It's in my syllabus. I have my office hours, which you're always invited to stop by and ask any questions. And realistically, also with Zoom, and because I could set up a Zoom, if you really, really need my help another time, let me know, and I'll see if I can schedule you in, because I want you all to do well. Now, the new substituents I taught you last time we met were chloro, Cl, bromo is for bromine, Br, iodine, I is called iodo, fluorine is called fluoro. By the way, this is one of my Freudian slips in organic chemistry. I always put my O first when I spell. I don't know why I always get that wrong. NO2 is nitro. These I'd like you to know. My tests for this course are not open note, and there are ways I can use technology to find out if you cheated. Please don't. So hopefully you'll start learning this. The sulfonic, I don't ask you to learn the name, but here's the group, and we'll talk about it. Why? Because this group's important for making your laundry detergent, which is a good thing. And you already know the alkyl groups. All right, let's do some more. Ask my thumbs up people. Can you now see this ring that I just drew? Thank you. Now, the question is, what's the Iupac name for this? And if we look at this, oh, a benzene ring. NO2 is a nitro group. When there's one substituent on a ring, you don't use numbers. So this would be nitro benzene. Oh, let me let you try one. And why don't you try this one? That's a BR. In case you didn't write it down, let's go back. Why don't you write these down real quick? The first 5, chloro, bromo, iodo, fluoro, and nitro. Hopefully you got those. When you're done, give me a thumbs up or smile or go, hi, Dr. White. I think everybody's done. So let's take a look at this. What is Br? Bromo. It's on a benzene ring. Now, Dr. White has a bad habit. At times he capitalizes things. If you were typing this out, they'd be all lowercase. But if you don't make upper and lowercase, Dr. White will never, ever take all points for that, because I'm guilty of it too. Let's try some more. And And I'll do this one. Now, if you notice, we have a benzene ring. Oh, we have two groups on there, a nitro group and a chloro. Now, if I call one of these 1, the other is 2. 1,2 disubstituted is ortho. I have chloro group. I have nitro group. Well, I've got a long name here. And I have benzene. And I think I'm still in the same state. Wow, that's a long name. Now, I'm not holding you to the alphabet rule for substituents. If you put the nitro first and the chloro second, I would still mark it correct. So this is orthochloronitrobenzene. And why don't you try this one? While you're doing that, I'll help you out a little. And for disubstituted, there's ortho, meta, and para. Seeing all my old regulars now. For those who came in late, one of the things I asked earlier, because I'm learning about it from an internet online course I'm taking on how to teach online courses that ECC is required, is on online, the socialization between you and me and you and your colleagues is way down. If you can think of ways of increasing that, I was thinking of maybe have some breakout rooms where you meet in small groups and talk about something and come back and discuss it with the whole group and other things. So if you think of something, let me know, because I definitely want to get the socialization up for our class. I think it'll be a good thing. I don't know if the school would want me to have a Friday night BYOB, BYOF, BYOWC party. Bring your own booze. If you're old enough, bring your own food, bring your own webcam. See, Dr. White is a tech power user, knows these things. Actually, I've been at Zoom parties. They're pretty wild. I had one with people in 5 different states I knew. That was amazing. All right, let's get to work. Question is, what's the Iupac name of this compound? 3 points. I have a benzene ring. I have chlorine, bromine. Notice 1, 2, 3. They're 1,3 disubstituted. 1,3 disubstituted. Oh, look, someone wrote a very nice chart on our screen. Meta, 1,3 disubstituted. Therefore, this would be meta, bromo, chloro, benzene. Now, if you put the chloro first and the bromo second, that's fine. Don't tell anybody I'm not holding you to the alphabet rule, but I won't. I hold myself to that, but that's because if I didn't, the Iupac police would arrest me. Actually, there are no Iupac. Oh, let's try another one. These are fun. I'll let you try this one on your own. See what a nice person I am. When you're done, give me a thumbs up. Even a little thumbs up, like, so it barely peaks above the screen. No, I'm just kidding now. All right, I think everybody's done. Let's take a look at this. All right, what do we have? Ooh, a benzene ring. But look, there's a methyl group on that. So this is now toluene. And I have an NO2 group, which is nitro. Now, it's di-substitutes, so I'm going to use ortho, meta, and para. If I call this 1, this is 2, this is 3, this is 4. And if we look to the nice table, someone was nice enough to write on here, we see 1, 4 is para. So that's para-nitrotoluene. Now, let's look at what if you have more than 2 groups? Then you use numbers. And let's give an example. This one here, the bond is to nitrogen, even though you usually see it written that way. I'll do this one. What do we have? We have a benzene ring. That's an awful looking arrow. That's better. And here, that's a better one. We also have a methyl group. So this is toluene. Now I have 1, no, 2, no, 3 nitro groups. Remember, di is 2 tri. Hold on 1 second. That looks better. Is 3. 4 is tetra. I haven't seen it in tetra in my career, so other than a bad joke that I won't tell you. So we'll leave it at that. So it's tri-nitro. Now, in toluene, when there's more than 2 groups, toluene mostly, and for this class always, will be 1. So either way, I number in the direction to give the substituents the lowest numbers. And either way, if I go clockwise or counterclockwise, I'll get the same results, 2, 4, 6. When you see tri, you need 3 numbers. So this is 2, 4, 6 trinitrotoluene. That looks better. It looked like a lightning bolt. 2, 4, 6 trinitrotoluene. 2, 4, 6 trinitrotoluene. Boy, that's really hurting my 2, 4, 6 trinitrotoluene. Did I tell you how lazy organic chemists are? We are. And if I go back to this, if I look at this name 2,4,6 trinitrotoluene, why don't I just be lazy and call it TNT? And by the way, that is the structure of the explosive TNT. Don't make any at home. This is a very dangerous compound. And TNT is 2,4,6 trinitrotoluene, and this is the correct Iupac name. This is abbreviation used and people use in everyday life. Time for a Dr. White story. Now, 2,4,6 trinitrotoluene is a liquid at room temperature and is very, very sensitive to shock. If this were a bottle of 2,4,6 trinitrotoluene, and I went like this, I'd be dead now. My house would be gone. My neighbor's house might be gone too. Well, luckily this is water. Well, it turned out when they were using it a lot for mining and other things, people are dying when they, especially back in the 1800s, if you had a horse-drawn wagon, you can imagine how rough the road is and bouncing on the wagon. Well, anyways, two brothers came up with an idea, and they came up where, how can we make that safe to use? And one of the ways was they mixed it with clay and formed it into sticks. And we now call that dynamite. And those two brothers were the Nobel brothers, Alfred, I can't remember his brother's name, I should, but I don't. Now, sad story. Making that stuff was still dangerous. And one of their plants blew up and killed Alfred's brother. Now, was that the motivation or not? But how many of you have heard of the Nobel Prizes? There's one in chemistry, one in medicine, one peace. That was set up by Alfred Nobel. Now, where did he get the money for his prizes? By selling explosives, his dynamite and other explosives. And who are the people who bought the most of that? Armies. Countries throughout the world for their armies, explosives for the military. So the amazing thing, most of the money that used came, or was how it was earned to set up the Nobel Prizes, came from warfare uses, which I find no problem with. It's just a fact of life. And next time you think about dynamite, think about Alfred Nobel and the Nobel Peace Prize. I always do, or chemistry too. By the way, the chemistry prize years ago became so political. It's not always, but a lot of times it is. And later on, I'll tell you a story about that. Somehow, I don't think I'm going to win one in my lifetime, even though it would be nice. But I've done some amazing things, but not Nobel. Actually, when I was at Michigan State, he had won it. One of the professors there, not who I work for, but another one, Dr. Grubbs, later on left Michigan State, went to Caltech, and he won the Nobel Prize while he was working there. And Dr. Grubbs was a really fun guy to be around and very brilliant, obviously. And you know, I'm going to give you one to try. And why don't you try this? These are both BRs. And what would be the Iupac name for that? 3 points each. All right, I think everybody's done because you're all looking at me like, get to work, Dr. White, so I will. Oh, what do we have? A benzene ring, but a methyl group, so that's toluene. And I have, a Br bromo. I've got two of them. Di is 2. Tri in organic chemistry or chemistry in general means 3. So this is a bromo group. There are 2 of them, so it's dibromo. And for toluene, this is always 1, and I'll go in the direction to give the other 2 the lowest numbers. If I went this way, counterclockwise, this would be 5, this would be 6, and I hope you all agree 2 and 3 are less than 5 and 6. Di tells me 2 of them, which means I need 2 numbers, and this would be 2,3-dibromotoluene. Now, when you're doing nomenclature, remember nomenclature is the fancy word for naming. There are 2 skills you should have in organic chemistry, which means 2 types of problems I can put on a test. First one is, here's the structure, give the Iupac name. The second one is, here's the structure, here's the name, draw the structure. Wake up, Ken, Dr. White. Hold on, I'm gonna do a reboot. Didn't know I had that switch back there. See, it's hidden back. No, I won't show it to you. Uh-oh, look, it's awful humor Monday. All right, let's try this one. And I'll do this one first. How do you decode the secret code in this words, the Iupac name, to know what to draw? You always start from the right and move left. So I see benzene, I know what that is. Remember, this is cyclohexane. Now it's benzene. Iodo, that's iodine. You can put it on any one of these. Most of you are going to put it on top. And let's assume this line goes there, and I'm done. Oh, I'm going to let you try one. And why don't you try this one for yourself? Draw the structure of chlorobenzene. I think everybody's done. Let's do this. How do you decode this? You start from the right, move left. Benzene, I know what that is. Remember, this is cyclohexane. And the reason I'm saying this is I had one student lose 12 points on a test for not putting the lines in her circle, making it benzene. And then chlorine is Cl. And you could put it on any one. Most of you are going to put it here. You could have just as easily done this. All I've done is rotate the ring. They're the same compound. Let's move on. I think you're getting the hang of this. And why don't you try this one? Draw the structure for Paraioto toluene. All right, I think everybody's done. Let's do it. How do you do it? You start from the right and go left. Toluene. Oh, I know what that is. Remember, put the lines or circle inside because this is methyl cyclohexane. Now it's toluene. Iodo is iodine. If this is 1, para means 1, 4, disubstituted. This is 1, 2, 3, 4. So I have my iodine there. Let's try one more. And why don't you draw the structure for 1,2-dichloro 4-nitrobenzene. Ooh, that's an interesting molecule. Then 3 points each, draw the following structure, 1,2-dichloro 4-nitrobenzene. In case you forgot, nitro is NO2. Thank you, Dr. White. You're welcome. I think, is everybody done? I think so. Let's do it. All right. How do you decode this? You start from the right and move left. Benzene. Oh, I know how to do that. And don't worry if your benzene rings aren't the most pretty. I don't take off points for as long as I can figure out, yeah, it's a benzene ring, but not this. This is cyclohexane. Now it's a benzene ring. That should be, let's, sorry about that. Now, I have a nitro group and di-2-chloro. Now notice one of them is on 1, so I'm going to make this 1. If I go clockwise, you could also go counterclockwise. Most of you won't do it. Dr. White does sometimes. That's 2, that's 3, that's 4, and there's my nitro group. 1, 2, dichloro, 4-nitrobenzene. And that's how you do nomenclature for aromatic compounds. Now, there's some other common names that I'm not going to ask you to learn, such as xylene, and other xylene is, I think, a 1,4 disubstituted benzene ring, but that won't be on the test. All right. Time out for a secret little thing that I've got today. Don't go rushing to the internet and let everybody know, but all faculty at ECC got today an email from Peggy Heinrich, Dr. Heinrich, who's the academic vice president. And it's an interesting email. I thought I'd share part of it with you. And she was talking about how in the next 7 days, we have to put in our picks for what classes we'd like to teach for spring. And that in itself is nothing new. What was interesting is, which I sort of figured, but now I know is ECC, and I'm sure other schools are figuring how things are right now due to COVID-19. Next spring, they'll still be the same way. If you look at some of the campuses you hear in the news, like where I got my PhD, Michigan State had a massive increase in people being affected by the virus and testing positive. And what she said was in our email, we're going to do it the same way we're doing this semester. If you can do it all online, do it. All lectures will be online. And the only reason if you have to do a lab at school, which luckily I figured out how to do 170 so you don't, but I just thought you'd be interested in that. All right, let's move on to aromatic compounds. Now, it turns out aromatic compounds are different than if you think about, here's benzene, the simplest of all. Well, isn't this like 1, 2, 3 double bonds? And similar, if you just had one, like cyclohexane, don't they react the same way? And the answer is no. If you add hydrogen to this, you know you can hydrogenate that double bond very simply. Benzene, no. Eventually you can, but you've got to beat on it. Very high temperatures, very long reaction time, I mean really long. So it doesn't react as if there were 3 separate double bonds. Something is different in benzene and actually in all aromatic compounds. And this is the thing that makes them also much more stable to change by just sitting around for eons. Switches off for this slide and the previous one. Hold on. Click. Will this be on a test? Switches off for this one. Next slide. Now, what is that difference? It's called stabilization energy, or I like the older name, resonance energy. And this is the difference between the energy of a real molecule and if you calculated that energy for the stable contributing structures like 3 double bonds in a ring. Aromatic compounds are much more stable than non-aromatic compounds, and this is due to resonance energy. And what we mean is, again, switches off. Each of these double bonds has 2 pi electrons. And as I showed you earlier, let me go back to it. This is really neat. See how they really exist this way, not as discrete double bonds, but Kekulé's concept helped us understand benzene by writing it this way. Think of them holding hands in a ring, like ring around the rosy, and they don't want to let go, because if they let go, they're no longer as strong. So guess what? In benzene chemistry, those double bonds don't want to react. It's very rare. So this lack of reactivity is due to resonance energy, because by holding hands, everybody hold hands with me, holding hands, those pi electrons are very stable. And in nature and in chemistry, you don't go from something stable to something unstable. It's like if I'm sitting here, all of a sudden you're not going to see me 3 feet off my chair because of gravity. I'm at my most stable position right now. Ooh, I threw in some physics. Oops. But anyways, that's stabilization. Oh, I should warn you. Ooh, exciting new word time. I'm going to teach you some new words. So what does that mean? That means in organic chemical reactions of aromatic compounds, you don't have addition reactions where you break the pi bond and add something to it. What you do have is electrophilic aromatic substitution. Well, I know what substitution is. I just replace one thing for another. aromatic, I'm dealing with aromatic compounds. What's this thing? Electrophilic. Well, phile from philic means lover. I think you've heard different types of blank files in the news, some good, some not. I'm an audiophile. What does that mean? I love music. If you look over, hold on, right there in the corner right there, you can see one of my speakers, actually three of them sort of hidden, with a tweeter on top for part of my office stereo. I think in my house I have 5 stereos. My big family room stereo I've had for many decades. It took me almost a year when I finally started looking to find all the components. I won't tell you the price because you'd rob my house then, so I won't, but it's quite expensive. I love music, especially acid rock, classical, and even bagpipe music. And I also somewhat play, but I love the banjo. Now, I'm not really a good banjo player, but I still love it. So electrophile, electro. Why am I thinking electron? Oh, what's the charge on electron? A negative. So an electrophilic substitution reaction is something that loves electrons. And where are their electrons? Well, those are electrons, the pi cloud, the donut. And electrophilic substitution reactions due to the resin, again, switches off for the slide, due to resin stabilization, aromatic compounds rarely undergo addition reaction. In this class, they don't. And aromatic compounds undergo substitution reactions. And these are chemical reactions where hydrogen atom on the aromatic carbon of the benzene ring is substituted with an atom or other group of atoms. And if I look at my clock, I see we're almost about time to stop. And I'm going to just give you a little teaser. The first one we'll talk about after our break is halogenation. And this is a reaction. And I'm going to let you out a whole 15 seconds early. Come back in 5 minutes at 1:55. Dr. White's going to stretch because it helps me from getting late cramps. You guys are younger, but still you should stretch. And I'll see you in 5. All right, I better get you guys back. Time to start again. I love this. By the way, the company that made this went out of business years ago, and you really can't get these. I have 3. I think I mentioned they never leave my house. They're too valuable. All right, let's get back to work. We're talking about aromatic compounds and the chemistry of the aromatic compounds. Now, the first reaction I'd like to talk about is called halogenation. And this is using electrophilic aromatic substitution. Now, in real life, the halogens, as you learned previously, abbreviated by X, can be fluorine, chlorine, bromine, or iodine. But in real life, and don't forget Dr. White worked in the real world of chemistry, X is usually chlorine and bromine, and that's all. Now, because this is a lot harder reaction to do than just halogenation, a double bond, you need a catalyst, ferric trihalide. So what happens is if you react benzene with a halogen and ferric trihalide, you replace one of the hydrogens with a halogen. Now, what you have left over is H and an X, and you get HX. Now, organic chemists are very biased about one thing: inorganic molecules. On my test, these type of problems, I will ask, give the organic product or product. Therefore, you never have to put HX down. Now, if that helps you do it right, you want to, feel free to. But if I don't grade it that way. So let's look at the following. And the question would be, give the organic product or products for the following reaction 3 points. Oh, what do I have here? A benzene ring. What am I reacting with? Bromine, that's a halogen. Ferric, that's an E. Now it looks better. Ferric trihalide, where X for my class is chlorine for this reaction, or bromine. And I'll replace one of the hydrogens with a halogen. If you want to put down HX, you can. I won't. Now, let's do this. Oh, I'm going to get benzene. Remember, this is cyclohexane. You have to either put a circle or the 3 double bonds. And I'll replace what's X. X is bromine. So I'll make bromobenzene. And that's how you do it. Sorry about that. I lost the toolbar. Your turn. What would be the organic product or products for the following reaction? Anybody need more time? Listening? Nope. Oh my gosh. I have something to tell you. You guys are doing well in organic, and it's not that painful, hopefully. All right, let's do this. What do we have? Benzene ring. What are we reacting it with? Oh, chlorine. That's a halogen, chlorine gas. Notice ferric trichloride. And I replace one of the hydrogens. Most you're going to put it on top. You could put it on any carbon with a halogen. You get HX, but that's an organic. We're not going to talk about that. What's X? Chlorine. Remember, this is cyclohexane. Don't forget to circle the bonds. Ooh, nice ring. And you get a chlorine on there. And you'd make chlorobenzene. Now, what I'm going to write on next, I'm going to turn the switch up. Will this be on a test to the off position? Let's say you have a benzene ring with something on there. And for some reason, organic chemists for aromatic compounds use the letter Z. Again, you don't have to write this down. And let's say I were doing a halogenation again. Now, unlike this, where every point on the ring is the same, when I have Z, I could put a halogen there. I could also put it there. And I could put it here. And if I put it on this side, this would be the same as this. If I put this on this side, they would be the same. So these are three possible compounds. And it turns out in organic chemistry, and I will not teach this to you in the class, but I will talk about it and we'll do a lab on this. This is called a director. And what's a director? Have you ever gone to those places like the DuPage County Fairground where they have an open field they made into a parking lot? They have those people talk, no, don't park there, park here. And they're directing you. They don't like me because I don't listen to them. Or if you go to a big concert and they do the same thing, they don't like me either because I'm not going to park there. But anyways, they're directing you where to go. Well, it turns out the group on a benzene ring and certain features about it tell you where the new groups are. And there are two types of directors. Again, switches off for this. And one group or type is called ortho pair director. And the other is just called the meta or director. If I can spell it right. And turns out, depending on what Z is, and I'll teach you later on about Z, you can get either ortho pair products or meta. Now, you could spend the next 2 weeks learning about different Z groups and learning it, and eventually you'd master it. Guess what? I'd rather, how many of you are planning on being organic chemists? Give me a thumbs up. No one, except me. And therefore, I'm not going to teach you directors for the test. Why? Because I'd rather spend more time on, well, maybe fats and oils, carbohydrates and proteins, which I think is more germane to things you're going to go into. So what does that mean? Good news. The only two reactions I can give you for this reaction are when X is bromine or chlorine, and that's it. So with that, we can move on. Let's look at the next case. This is called nitration. Nitration is when you react nitric acid with sulfuric acid and a benzene ring, and you put a nitro group on it. Never try this at home, because this is the way you can make explosives, by putting nitro groups on there. But I'm going to only ask you one. Where's the example? Right here, because I'm not going to teach you directors. So the only reaction you have to know is this. Now, what I will show you is the following. This will not be on a test, but it may help you a little. Think of nitric acid as this, HO and NO2. And think of sulfuric acid as an acid of way of H+. And H+ is the way we do general acids in organic chemistry. Well, if this reacts, you'll get this. And normally, if we were in a class, I'd use my hand and cover the nitro group. I can't do that on my screen, but I can do this. See what's in the dotted circle there? Red? Looks familiar. 2 hydrogens, oxygen. 2 hydrogens, oxygen. What could that be? It's water. And whenever you can form in a molecule a stable leaving group, it says, goodbye, I'm out of here. This loses water to form what's called the nitronium ion. And this is not happy. It's looking for electrons in the worst way. And where can it find electrons? Right here. And it does. And this loses H+, which you originally added here. So you get back your calculus, and we usually don't show that. And that's how you nitrate a benzene ring. So the only reaction I could give you on a test, I shouldn't be telling you this, but it's true. And why don't you try this one? Give the organic product or products for the following. I'll give you 7.6 seconds to do it. Go. Time's up. And all you have to do is look up here. And the answer is this again. Now, something very important. Common mistake on test 1. People see the O3 here. Instead of 2, they do NO3. And that's wrong. And I'll give you 0 points. Wrong. It's NO2. And here you learned why. Here's 1, 2, 3. This becomes, when it reacts with the acid, this becomes this too. So make sure that's an NO2 group. On inorganic chemistry, I know of no NO3 products. It's always a nitro, NO2. All right, the next one is sulfonation. And sulfonation is where you take a benzene ring, react it with sulfur trioxide and sulfuric acid. And similar, and I won't show it here, but similar to what happened with nitric acid and sulfuric, same thing happens with sulfur trioxide. It forms an electrophile, something that loves electrons and puts on the sulfonic acid group. And I'm going to sneeze in a second. I think I stifled it now. Slow coming sneeze. Oh, excuse me. That was a slow arriving sneeze. But this is called sulfonation. And this was discovered at the end of World War II. And by doing this, organic chemists were able to take this compound, make something else, and that's the basis for the key ingredient, which I'll teach you in about 12 weeks in your laundry detergents. So this is the only reaction I can give you, because we're not covering directors. So let's do it. I'll give you 6.2 seconds. Go. What's the organic product or product for the following? Time's up. All you have to do is look right up here and you see benzene ring. Remember, this is cyclohexane. You either need to put a circle or the bonds. And this is SO3H. Now, sometimes students will put a 4 there or put this. That's wrong. It even says it on your screen. It's wrong. Remember, put the H there. And like I said, that's a common mistake. Why am I telling you this? So you don't make it on test number 1. For those who came in late, remember test number 1 will be postponed. It will be a week from this Wednesday, as opposed to this Wednesday. Be postponed. It will be a week from this Wednesday, not this Wednesday. Now, finally, the last reaction, Friedel-Crafts alkylation. Now, for the last about 30 years, it's sort of fallen out of practice, but for many decades, eons, in organic chemistry, if you discovered or really invented a very special reaction that people thought, wow, this is important, your name was put on that reaction. It was named after you. In my lifetime, in the last 20, 30 years, that's almost disappeared. But 2 organic chemists, and I believe British, Friedels and Kraft, discovered some amazing stuff. And they have their name attached to Friedels and Kraft's alkylation. By the way, my favorite reaction, which I won't teach you in this class, is the Hels-Volhard-Zelinsky reaction, which I know. I always think that's a cute name. And 3 organic chemists, Hels, Volhard, and Zelinsky, worked together to come up with that. But we're not going to do it. I just think it's my favorite name. I see a question or two. Barb asks, why did you add the H? Because for the last reaction, I assume that's what you're talking about. Let's go back. Oh, before I do that, remember, in my class, all questions are good questions. As I like to say, there's no such thing as a dumb question. Oh, I must have had it on the other slide. Why was there no H? Because I was showing you it's wrong. When you put the H there, this is what is put on. How do we know that? Well, organic chemists in the lab approve SO3H is put on there when you react sulfur trioxide, sulfuric acid. If you're interested, after class, stick around and I'll show you the mechanism how sulfur trioxide reacts with H plus to form SO3H plus, which attacks the ring and gives off H plus to form the sulfur trioxide. Okay. All right. And let me just check. Barb, did that answer your question? Give me a thumbs up or say yes. Okay. Thank you for your thumbs up. All right, let's talk about Friedel-Crafts alkylation. Now, as you know, this is a benzene ring. Since we're not using directors, I will always show you this with a benzene ring. Here I have RX and aluminum trihalide. For this reaction, X is almost exclusively this chlorine or bromine. I've never seen it as fluorine or iodine. R means anything with carbons and hydrogens. And what this means is if I react the benzene ring with an alkyl halide with this aluminum trihalide, I'll replace one of the hydrogens with R. You'll get HX, but that's an organic. We don't like that. Organic chemists are biased. But if you want to put it down, all right. And you put an R group. R group we call alkyl, and that's why this is called alkylation. Now, look very closely at something very special, so special, I'm going to get my red pen out. What we've made is a carbon-carbon single bond. This is very rare. In all of organic chemistry, Dr. White only knows about 15, 20 reactions that you can make carbon-carbon single bonds. Very rare. So very special and fun to do. And when you can, that's a good thing, very special, which is why they won the Nobel Prize for discovering this. Again, it's very rare to make carbon-carbon single bonds. Other bonds I can do like that. I think I know about 400 general reactions. Relax, I'm only going to teach about 50 in this class, but the number of carbon-carbon single bond, making a carbon-carbon single bond, are very special, very rare, and very good. And this is one of them. So let's look. So here's Friedel-Crafts alkylation. Let's do an example for you. Now, let's take a look at this reaction. What do we have? A benzene ring. Again, look for what's different. What's not carbon-carbon single bond should get your attention. And the three bonds that are conjugated should get there. Let's look at this molecule right here. What's different? What's not a carbon-carbon single bond and what's not a carbon-hydrogen bond? And right there, a chlorine. And how do we abbreviate that? RX, notice I have aluminum trihalide. Yeah. Did it again. And X can be chlorine or bromine. And what happens, you replace one of the carbons on the benzene ring with an alkyl group, and you made that very special carbon-carbon single bond. Now, listen carefully. The carbon with the halogen will be the carbon in the R group that's bonded to the benzene ring. The carbon with the halogen will be the carbon in R bonded to that. Also, do you break carbon-carbon single bonds? No. So I have my benzene ring. What carbon of 3 carbons has the halogen? The N carbon. The other 2 will come along for the ride. And I've made that special compound, well, this one, N-propylbenzene. Now, sometimes if the molecule's too big, we don't put it on top of the arrow. And this would be an example. Your turn. What would be the organic product or products for the following reaction? Now we're getting in some juicy stuff, the good stuff. Remember, if you're having any difficulty with this, always feel free to stay after class for a little while, because Dr. White doesn't have to leave because I'm already home. And I'll make some extra time or come to my office hours. I'm always here to help you because I'm very selfish. It makes me feel good when students get good grades. When you're done, give me a thumbs up. All right, anybody need more time? No, nobody yelled, so let's do it. All right, let's look at what are we starting with? What's different? Ooh, benzene ring. What's different here? Carbon, carbon, hydrogen, a carbon with a halogen. And aluminum trihalide. And remember, X here can be chlorine or bromine. And therefore, Friedel-Crafts alkylation, and we get to make that something very special, and that is a carbon-carbon single bond right there. What's our R group? This right here, isopropyl. Which carbon is bonded to the halogen? This carbon. So that's the carbon in R that's going to be bonded to the benzene ring. Therefore, my general reaction tells me I have my benzene ring. I have 3 carbons. You don't break carbon-carbon single bonds. I have 3 carbons. The center carbon is bonded to the isopropyl ring, to the benzene ring, which is an isopropyl group. Remember, there are 4 bonds to carbon, and I've just made isopropyl benzene. Oh, this is fun. Let's do another one. And here you go. I'll share and let you have some fun. If you react these 2 together, what are the organic product or products? 3 points each. Checking all of you working on the problems. And when you're done, give me a thumbs up. I see some people are done. Remember, I try and give everybody opportunity to work on all the problems. So if you're done early, please be patient. All right, looks like everybody's done. Anybody not? Yell out? Nope. Let's go. All right. How do you do these? You look at the different molecules involved and identify what's different. Oh, double bonds, 3 of them conjugated. Benzene ring. Ooh, carbon, carbon, carbon. Wait a second. What do we have that's different? A halogen on a carbon. So this is the alkyl halide. And I'm reacting it with aluminum trihalide. Remember, X can be chlorine or bromine. And what do you get? You do that special thing. You form a carbon-carbon single bond. Remember, R is anything with carbon hydrogen. And hold on 1 second. Let's try this again. In a classroom on a whiteboard, sometimes even Dr. White has bad drawing days, and you get an R group on there. Now, what's our R? Here. And here, anything attached to the carbon with the halogen on it. Here. Do you break carbon-carbon single bonds? No. So that R group better end up with 4 carbons. The carbon with the halogen is the carbon here in R attached to my benzene ring. Well, now that I know that, I have my benzene ring. Remember, this is cyclohexane. Put the lines or circle, double bonds or circle. My R group, I have 4 carbons. Which carbon has the halogen, the second one, and the second one will be the one bonded to the benzene ring. And I know there are 4 bonds to carbon, so I can put in my hydrogens. and I'm done. Now, on test number 1, for all the general reactions, aromatic and the alkene and alkyne, I will have picked from all those one synthesis problem, 4 points. So let's try one. Now, when I was undergrad, my instructor wasn't nice enough to put the question marks, but this tells you you have 2 products you have to fill in. Well, how do you do that? Well, you look at the product and say, what's different? Ooh, a benzene ring, but it's got stuff on there, R group. So what I have is this. What am I reacting with? Aluminum trichloride. I know that's this, where X equals chlorine or bromine. And what do I start with? Benzene plus Rx. Now, in this case, one of the question marks will be benzene. Doesn't matter which one you put first or second in my test. Now, what's the R group? Well, if we look here, how many carbons? 1, 2, 3, 4, 5. Which carbon is bonded to the benzene ring? The end one. And that's the carbon that will have the halogen. What's the halogen? Chlorine. So now I have 5 carbons, 5 carbons. The end one, you could put it here or here, doesn't matter. I'll put it here, has a chlorine, and then I put in the hydrogens. Let me discuss this again. What do? You look here, what's different? Benzene ring and my R group. What am I reacting? Something, 2 things, something, with aluminum trichloride to make this. What's this? R. What's this? Benzene ring. Aluminum trihalide, Friedel-Crafts alkylation. You have to remember this. Benzene ring plus an alkyl halide. One of the answers is benzene. My R is 5 carbons. 1, 2, 3, 4, 5. The N carbon, which you could have put here, which I did, or here, that would be CH2Cl. This would become Cl, CH3. Either way, you're just rotating the molecule, and that's how you do it. Oh, guess what? It's time for you to have some fun. And remember, these are more challenging than the reactions you've been doing, but only put 1 on the test for all the reactions for test 1. Your turn, go. What would be the organic starting materials for this reaction? And there are 2 of them, because there are 2 question marks that I'll provide on the test. Those who have guests with you, that's permitted. Those who have guests, don't forget to teach them this. See how dangerous Dr. White is? I've already got you brainwashed. All I got to do is this, and you know what I'm talking about? I had one semester, I had a student who was quite pregnant by the end of the semester. And afterward, she gave birth about a week and a half after the final. So a nice, beautiful daughter. And she emailed me and said, I'd just like to let you know, my daughter was nice enough to give birth. I'll wait until a week and a half after your final to get born. And I said, wrote back to her, well, since she was with you the whole semester, you know, being pregnant, I said, did she learn there were 4 bonds to carbon? Was the first thing she did after she was born, hold up her hand and go like this to you? And new mother loved that. She said, no, she waited 2 weeks. All right, let's get back to work. All right, how do you do this? How do you determine what's the product or products to this reaction? Well, you look at the, starting material. This is a halogen, aluminum trihalide. X can be chlorine or bromine. Next, we have, a benzene ring. That's different. Is there anything on here? Yes. If we look here, we've got carbons and hydrogens. That's an alkyl group. How do we show that in organic chemistry? With the letter R. How do I make this? Oh, that's Friedel-Crafts alkylation, where you take benzene plus alkyl halide. What's my halogen? Bromine. What's my R group? A T-butyl group. Therefore, it doesn't matter which one you write first. I have benzene, and then I have a T-butyl group. That's an R. Put in the hydrogens. Now, if you don't put the plus sign there, that's okay. I'm not gonna ever take all points for this. Now, this molecule here, you could have also written this way. All I'm doing is rotating it 90 degrees clockwise, and which is correct, either one. And that's how you do synthesis. And guess what? I'm teaching you some of the really tough stuff in organic chemistry, and you're doing it. Doesn't that feel good? It should. You should be very proud of yourself. Everybody, take a second and pat yourself on the back, or stand in front of a mirror and say, you're learning organic chemistry. I'm proud of you. By the way, in real life, and I learned this as a manager in the chemical industry, a lot of times people don't give themselves credit for that. That's something I was one of the rare managers who would tell people, take time, you did something good. So remember to do that. And that's aromatic compounds. All right, let's move on. Now, there's an area which I'd like you to know about, and I'm not going to put this on the test, so therefore I can go like this, click, will this be on the test? I hope you enjoy me doing that and that helps you out, but it's still something I'd like you to know for my class. And that's dealing with polyatomic or polycyclic aromatic hydrocarbons. And hydrocarbon means molecules with only carbon and hydrogen. Aromatic has 2n plus 4 pi electrons, and poly means many cyclic rings. And these are aromatic compounds or hydrocarbons with more than one ring. Now, one of the things I haven't taught you in this class is you can have molecules that share carbons where you have fused rings. These are 2 rings. And Dr. White worked with a very complex ring system for my PhD thesis. And this is 3 rings. I'm not going to, or no, 2 rings. I'm sorry. Another product I used 3, but this is 2 rings. This is called 222 or bicyclo 222 octanone, which is an old friend of mine. Say hello to my old friend a long time ago, but we're not going to do this in the class. But what I would like you to know is this is one. Notice it has alternating double, single, double, single, double, single, double, single, double, single. And this has 2, 4, 6, 8, 10 pi electrons. And you can solve this to have 10. When n is 3, 6 plus 4 is 10. This is called naphthalene. That's the common name. And I think it's also the Iupac, but don't quote me on that. And this is the active ingredient in mothballs. If you are old enough to remember mothballs, my grandparents' parents used them. They kept moths away from your wool stuff, because otherwise they'd eat holes into it. Now, I would like to teach you about a very important aromatic compound, and that's called graphite. And this is like large sheets of paper or the sheets of polycyclic aromatic carbon 6-membered rings used for lead and lead pencils. Let's go out into the real world. Oh, look, a YouTube star. If you go to Wikipedia, they talk about graphite. If you scroll down, you'll see these pretty pictures. This is my favorite. And think of each one of these 6-membered rings as having double bonds and aromatic. And you have sheets of these layered on top of each other in graphite. And these sheets, each one of these sheets is very strong, but between the 2 sheets, it's like sheets of paper, it's weak. Therefore, you can pull the sheets off. I've got a fancy one. This is an old friend of mine I've had for I don't know how many decades. It's a mechanical lead pencil. Look at, is that cool? Retractable tip. But anyways, it's got lead in there. Do I have any nearby? You know, the stuff you buy like this, lead. And what is lead? Guess what? Since the Roman times, lead hasn't had actual lead in there. It has graphite. And what happens is when you write, you're taking off sheets of the graphite and leaving it on the piece of paper. Now, those individual sheets are called graphene. And for many eons, chemists said, no, you can't isolate one graphene. Then about in the mid-teens, I think about 2015, wrong century, 2015, these 2 very brilliant or very clever chemists, I don't even think they were chemists, found a way to remove and isolate single sheets of graphene from graphite. What they used was an old crystallographer's technique in chemistry. Put some Scotch tape on it, carefully pull it off, dissolve the Scotch tape. What's on there just floats around. Well, nobody had ever thought to do that with graphite to make graphene, and they did. And because of that, they won the Nobel Prize. for using Scotch tape, which at first glance you say, no, they deserved it. They proved you could make something that nobody else could and everybody thought you couldn't. Sheets of graphite. And why is that important? Those sheets are super strong, super light. And because of that, a whole new area opened up actually a little before that called Nano Chemistry or Nanocarbons. And those are very thin sheets of carbon that are nano, 10 to the minus 9, like a piece of paper. Before they isolated the single sheets from graphite, Smalley of Texas, and I forgot the Japanese organic chemist, found a way of treating graphite and taking those sheets while it's still on graphite to make a tube. And these are called nanotubes. This was in 95 or 96, about a little before they found out how to make individual sheets directly with the Scotch tape, and now other ways they're finding. These are super strong as steel, but as light as fiber carbons and carbon fibers. Got that name backwards. And because of that, think about it. If I can make a jet out of nanotubes, it would be super light and super strong. And think of all the jet fuel, I would say. Same thing out your cars. Since 95, all the governments like the United States, Germany, England, Japan, Russia, China have been pumping billions per year into that research. And some of it's paid off. So this is what's used for in graphite. These sheets come off and you write on a piece of paper. And as I mentioned, nanotubes from the can be made. They're finding ways of making larger quantities, but it's so expensive. In fact, that's a problem I've worked on personally for myself, because if you can find a way to make nanotubes of graphite super cheap in ton quantities, you'd be quite rich. Nobody's done that. Oh my God, I went over. I was having such a good time. Dr. White went over. All right, everybody, let's take a 5-minute break. Come back at 2:55. I'm going to keep my eye on the clock better. And some of you said, you're running late, like that or something. But see you in 5. Dr. White's going to stretch. I better call you back to class. Love it. And it works too. All right. Let's continue on. Now, if you look here, look at the bottom. We're on page, you sort of can see it, sort of can't. We're on page 24. And you know what that means? We're done with the aromatic compounds. And what that also means is I've covered everything that will be on test number 1. I like to end a week or so before, so you have plenty of time. Remember, on Wednesday, I will do the alkenes, alkynes problem set. Also, we'll have a new lab to do. Also, a week from today, I will go through the aromatic problem set. And I will do my world famous review for test number 1. It is world famous, in case you don't know. And be sure to do the practice problems before I go through them. That way you'll do good on a test. Remember, I talked about riding a bicycle. You don't practice, you don't get good. And where do you want to fall off, on my test or on the practice problems first? We'll do that. Again, Wednesday, alkenes and alkynes, and next Monday, aromatic and the review, plus some other stuff. So, you know what time it is? By the way, I used to have a class a couple years ago. Every time I said that, they close their notes, start packing. No, it's not time to leave. It's, guess what time it is? It's new chapter, new functional group time. And this new chapter will be, let's find out, alcohols, phenols, and thiols. Now, I'll give you some coming attractions. This chapter, I'll talk about some things you'd think I wouldn't get into, which are quite interesting to talk about, but I'm an organic chemist. I'll also talk to you about something, why Dr. White loves T-butyl groups. And finally, or actually second to finally, is that a real term? But anyways, second to last, I'll talk about a very sad tragedy and how organic chemistry now helps so that tragedy doesn't happen again. And the last thing I'll talk about, are you ready for this? Got everybody's attention? I'll talk about something that really stinks. I mean, really stinks. Really stinks. So that's the coming attractions. Let's get into it. Let's talk about alcohols and other things. By the way, we can still talk about it even if you're not over 21. Now, what is an alcohol? The general formula for an alcohol is any molecule that has a carbon. Remember, R means carbon, anything with carbons that has OH, which we call the hydroxyl group. Let me write that better. And sometimes Dr. White will get lazy and call that a hydroxy group. It's really hydroxyl. I've somehow dropped the L, but it's a hydroxyl group. I'll never ask on tests what is OH, but I'll use that terminology. So anything that has hydroxyl group on R is an alcohol. Now, coming attractions. Next number of chapters, I'll start out. I'll introduce you to functional group, like here's an alcohol, say hello. And then I'll talk about How do you use the Iupac rules to name that? And how do you take the name and draw the structure? I'll also throw in along the way where you find these things. And since we're getting into more interesting part and older parts of organic chemistry, I'll also teach you what's called the common names, which happened long before Iupac, but people still use them. And then we'll get into the good stuff, the chemistry, how they react and how you make them. And remember, the general reactions I'm teaching you are building blocks organic chemists use to make molecules you use in your daily life. Just like a carpenter uses a 2x4 or a nail or a hammer to build things. Organic chemists use the general reactions. Those are the fun part. But then again, I'm a synthetic organic chemist. So if we look at the rules, and hold on one second, because I just closed the wrong thing. All right, let's look at the following. And let's look at this molecule. Since I've been playing around with everything, better check. Thumbs up, people. Can you see that molecule I just drew? Thank you. I appreciate your help. All right, as I mentioned, whenever you look at an organic molecule, look for what's different. What's not a carbon-carbon single bond or carbon-hydrogen bond. If we look at this molecule, it's like a flashing red or blue light, and that is hydroxyl group. And it's on a carbon. And what do we call that? Hydroxyl group on a carbon. Hydroxyl group, and we call that an alcohol. Now the question is, how do you name this? What are the Iupac rules? I will never ask you on a test, give the Iupac rules for something, but I will ask you to know how to use them. So let's take a look at the Iupac rules for alcohols. The hydroxyl group OH in an alcohol is indicated by changing the ANE ending of the longest carbon chain, named as an alkane, doesn't say that, with the hydroxyl group to an ANOL. What you do is you drop the E and add OL. Next thing, a number is used to denote the carbon the hydroxyl group is on. Now, a carbon with a functional group, in this case hydroxyl group, is always numbered to get the lowest number. Now in this class, I will not teach the Iupac rules, which I know, but you won't use in my class. What happens if you have hydroxyl group and a double bond or triple bond? Well, there's priorities, which gets the lower number over the other. I know those rules. You can breathe easy. You won't use those in my class. And then for alcohols, the rest of the Iupac rules are followed, except the hydroxyl group has priority in the numbering system. So let's go back and look, excuse me, at our example. Now, what's the longest chain that has the carbon with the hydroxyl group? 1, 2, 3, 4, 5. Hopefully you've learned the alkanes, 5 carbons is pentane. But it's an alcohol, Y, hydroxyl group. I'm going to drop the E at the end of pentane and use an OL. OL ending, alcohol. Now, which carbon is the hydroxyl group on? Well, if I start from here, from this end, remember you always start numbering the chains from the ends, it's on carbon 2. I start from the other end, this would be 1, 2, 3, 4. Now you have to use your high-level math skills, which is the lower number, 2 or 4, and hopefully I'll pick 2. So what carbon is the hydroxyl group on? Excuse me, 2. So this would be 2-pentanol. Water break. Boy, this alcohol stuff is thirsty work. All right, let's go through this again. Look for what's different. Hydroxyl group on carbon. Remember, what's not a carbon-carbon single bond or carbon-hydrogen bond. Get your attention like that, actually faster. And then find the longest chain that the carbon, the hydroxyl group is on. Name it as an alkane, pentane, drop the E, add OL. OL tells you alcohol. And then which carbon is it on? Your turn. What would be the Iupac name for the following molecule? Go. I see everybody out there having fun. All right, looks like everybody's done. I better get to work. And let's do this. When we look at this, what's different? What's not carbon-carbon single bond or carbon? Ooh, an oxygen with a hydrogen, hydroxyl group on a carbon. That's an alcohol. And how do we name alcohols? We find the longest chain with the hydroxyl group and name that chain as an alkane. In this case, it's 1, 2, 3, 4. Oh, that's butane, because you learned that. Hint, hint, big hint. Drop the E, because we have an alcohol. We add OL, and that would be butanol. Am I done? No. I need to say what carbon is my hydroxyl group on. And it's on carbon 1. If I start from this side, it would be carbon 4, 1, 2, 3, 4, which is smaller number, 1 or 4, times up. And that would be 1-butanol. And that's how you do it. Oh, let's do some more. These are fun. Now, one thing I should tell you, something personal about me. Dr. White had an instructor who always put his hydroxyl groups on the right, not on the left, and I still do that. Good habits I don't break. And most of the examples and things, you'll see me doing that in this class. And why don't you try this one? What would be the Iupac name, 3 points each, for this compound? You can see all of you working on your problems. If I were in a class, I'd be doing the same thing. I see one person giving me a thumbs up. I see a couple others, but I see some people still working. Take your time. I give everybody an opportunity to finish. And I think the last carbon or letter just went down. So let's take a look at this. When you look at an organic molecule, and I'll be saying this the rest of the semester, and Dr. White does this all the time. You look for what's different, what's not carbon, carbon single bond, carbon, hydrogen bond. Oh, oxygen with a hydrogen on a carbon. What is that? An alcohol. And now we have to find what's the longest chain with the carbon that's on, has the hydroxyl group. I could go 1, 2, 3, 4. That's one chain. I go 1, 2, 3, 4, 5, 6. I hope you all agree 6 is greater than 4. So 6 is hexane. I'll drop the E there, replace it with OL, because that's what we use for alcohol. What carbon is it on? It's on carbon 1, so that's 1 hexanol. As soon as I say this is all spoken for. Are we done? No, look, it's your good friend, the methyl group. And it's on what carbon? Remember, we're not doing the red. It's on carbon 3. So we have 3-methyl, 1-hexanol. Oh, let's do one more of these because they're fun. And here's the molecule. By the way, tonight on Zoom at midnight, I'll be giving speed structure drawing lessons. No, I won't. What would be the Iupac name for the following molecule? Have fun. Those of you who are turning on your video, thank you, because I can now see when you're done or not. That helps me. And those who don't or don't have, don't forget to use the thumbs up symbol when you're done. Got it. Some other people are still working, so I'll give everybody a chance. Remember, if you're having problems and you don't feel comfortable asking during the lecture, feel free to stay afterward or come to my office hours because I'm always here to help you. Anybody need more time? Going once? Going twice? So, by the way, when I was years ago, my brother-in-law, who unfortunately passed away 2 years ago, we were good friends, used to take me to auctions, and that's why I do that. I'll tell that story another day. All right. What's the Iupac name for this molecule? What do? You look for what's different. What's not a carbon-carbon single bond, carbon hydrogen. Oh, look, OH group, hydroxyl on a carbon. What do we call that? Alcohol. And how do we find the name? You find the longest chain that has the hydroxyl group on it, and that will be 1, 2, 3, 4, 5, 6, 7, 8. Did I count correctly? 1, 2, 3, 4, 5, 6, 7, 8. Now, if I went this way, 1, 2, 3, 4, 5, 6, that's less. 1, 2, 3, 4, 5, 6. This would be 5, 6. This would be 6 also. So 8 is the longest chain. If I counted correctly, which I think I did, 8 is an alkane octane. You drop the E because it's an alcohol. You add OL, octanol. Which carbon is the hydroxyl group on? We started from this end, it would be on 7. We start from this end, which you should. It's on carbon 2, so this is now 2-octanol. And as soon as I say that, actually, that's all spoken. Oh, look, we have a methyl group and an isopropyl. And notice the methyl group is on carbon 5. The isopropyl is on 4. So this would be 5-methyl, 4-isopropyl. Well, I just got that in. 2-octanol. There'd be a line there. Now, if you put 4-isopropyl, 5-methyl, I would mark that correct because I'm not asking you to follow the Iupac alphabet rules, but I do. Now, quick thing. Any questions so far? How are things going out there in internet land? Good. Let's talk about rings. Dr. White and Mother Nature love rings, students don't. How do you name that? Oh, what's different? Hydroxyl group on carbon. That's an alcohol. How do you name it? In this case, find the ring. Name it as a cycloalkane. Remember cyclo, and this is 5 carbons, pentane. And now drop the E, add OL. When it's the only thing on the ring, this is always going to be 1. Everybody knows that, and you don't need a number. I'm done. Oh, let me have you try one. give the Iupac name for this molecule. I think everybody's done. Let's get to it. Now, look at a molecule. Look for what's different. What's not carbon-carbon single bond, carbon, ooh, OH group on a carbon. That's an alcohol. I apologize if any of you tonight have nightmares saying, oh, look, OH group, it's an alcohol, but I'm brainwashing you, and it works too. How do you name it? And it's on a ring. Yes, that's not a square, it's a ring. This is organic chemistry. 4 carbons, every bend of the line is carbon. 4 carbon, ring, cyclo, don't forget to put the word cyclo, and butane, if it was a cycloalkane, it's an alcohol. So we drop the E and add OL, cyclobutanol, no number. Now, next question is, what would be the Iupac name for this? And I'll do this one. Just like in an acyclic alcohol and a cyclic alcohol in a ring, the carbon with the hydrox group gets the lowest number, which will always be 1 when there are no other functional groups, which is how it will always be on my test. And therefore, if this is 1, this is 2, you number in the direction to give the alkyl groups the lowest numbers. So this would be 6-membered ring, cyclohexane. It's an alcohol. Why? Because you have a hydroxyl group on a carbon, and therefore you drop the E, add OL, and I have here 1, 2, 3, 4 carbons to the N carbon. That's N-butyl group, and it's on carbon 3. And that's how you do it. And now it's your turn to have some fun. Looking at everybody working on it. Through the power of the internet, I can see you sometimes. Oh, it's Stinky Humor Monday. You even have to pay for this. All right, I think everybody's done. Let's do it. We look here and what's different. Oxygen. I don't know why it's disappearing on me. Ah. Sorry about that. This just burped on me for no reason at all. All right, let me rewrite this. And here we have a ring, but what's different, what's not carbon-carbon single bond or carbon-hydrogen bond, hydroxyl group, OH on carbon, and you know that's an alcohol. And what's the longest chain? Oh, we've got a ring, 5 carbons, cyclopentane. It's an alcohol. I drop the E and replace it with OL. And then, oh, look, I have 2 carbons. That's an ethyl group. Hopefully you've learned those. If not, practice them. This is carbon 1, that's carbon 2. And that would be 2-ethyl cyclopentanol. By the way, there shouldn't be spaces here, but if your spaces are not larger than being it on the next page, it's all right with Dr. White. Keep them close together. Now, I'm going to talk about something I'm in no way implying you should ever buy or consume what I'm going to talk about, but this is organic chemistry, and I should talk about it. Let's look at a very small alcohol. And the question is, what's the name of this? Well, it's an alcohol because I have a hydroxyl group on a carbon. And I have 2 carbons, that's ethane. And I drop the E, add OL, ethanol. Now I'm done, because if this is carbon 1, there's no way I could have 2 ethanol, because if I put it on this carbon right here, it would still be 1 ethanol. And therefore, we have no number here when there's no way you can have another isomer. And this is ethanol. And this little molecule is responsible for, guess what? It's responsible for, if you consume it, which I'm not telling you should, you get inebriated, which is a fancy way of saying drunk. And that's the molecule that does that. How it does that, I have no idea. I'm an organic chemist, not a medical doctor. That's not my specialty, even though Dr. White likes his ethanol. And that is, I'm a vodka drinker. Both my grandparents were Russian, which, you know, Russians love vodka. I love Grey Goose, Absolute. And you know, it's a really inexpensive, good vodka. And only if you're old enough to buy it. You go to Costco, they're more expensive French, not the American cheaper stuff vodka. And it's about this close to Grey Goose, which is a top vodka. Now, I have to, oh, I do. Oh, not much, but do. As I mentioned, time for Dr. White's story. I used to work for 2 Anglo-Dutch, really Dutch companies. So I made it to the Netherlands a lot. By the way, if you've never been to the Netherlands, you're missing a lot. And hopefully when this virus is all done and safe to travel, you'll go there. And probably one of the best cities in the world is Amsterdam. I used to tell people, if you're not having a good time in Amsterdam, you know what that means? You're dead, because it's a fun city. Now, in the Netherlands, back then when I used to go, I still have just the bottles in a liter clay bottle. You could buy what's called Neue Geneva, which is also known as New Geneva, which is essentially vodka. And with the exchange rate, I could get a liter for about $4 or $5. And I would always bring back a lot of Geneva on the plane. But let's get back to alcohols. Now, before I leave, there are 2 types of nomenclature questions. One is, here's the name, or here's the structure, give the Iupac name. And the other is, here's the name, draw the structure. And let's do that. How do you determine what the structure is? On a test, it would say and you might see this and you say, what do I do? Well, how do you decode this? You start from the right and you move left. OL ending tells you alcohol. And if this were an E hexane, 6 carbons. And you know the draw 6 carbons. And start for this one, either end. Dr. White likes starting on the right because that's what my instructor did. And good habits I don't change. 1, 2, 3. And I'll put the hydroxyl group on that carbon. And I better do it because I haven't done it a while. Get your attention. Got your attention. Remember, there's 4 bonds to carbon. 4. Yes, 4. And therefore, I know how to put in the hydrogens. And that's how you do it. Well, I'm going to share the fun because, you know, I like to. And why don't you have some fun drawing 2-methyl, 1-nonanol? Say that 5 times quickly. That's a mouthful. Remember, if you're done early, be patient because I leave everybody time, like you who's done early. Or if when you're done, give me a thumbs up. Or I guess if you're upset with me, you can give me a thumbs down. Don't. This is nicer. I did say it's awful Monday humor. All right. Is everybody done? Not yet. All right. Saw the last hydrogen just go down. Let's do this. Thank you all for giving the thumbs up. How do you decode this to know what to draw? You start from the right and move left. OL ending, alcohol. And if we look at this, if this were an E, that would be nonane. Nonane, I better get to work, is 9 carbons. And then the hydroxyl group is on carbon 1. I'm going to put it on this side. You put it on this side, that's okay too, but Dr. White likes putting it on the right. This is carbon 1. I keep on going this way. Oh, methyl group, what carbon is it on? Carbon 2. Remember, hydroxyl group counts as 1 bond, so I know how many hydrogens. and one nonenal, 9 carbons. It's on carbon 1. On carbon 2 is a methyl group, which I've got. I'm done. Let's try one more. Hold on a second. One of the things I forgot to mention in this class is the 20-second rule. Give me 20 seconds, because once in a while I'll change my mind. I'm doing these on the fly. And why don't you try this? Draw the structure for 3,3-diethyl cyclohexanol. Get moving. All right, who played with my clocks? Looks like we're almost done, and it seems like we just started. Time flies when you're having fun with Dr. White and organic chemistry. When you're done, give me a thumbs up. Or give me the high sign. No, I just did a generation gap thing on you. All right, let's go ahead because we're almost out of time. How do you know what to draw here? You look here and see OL ending, OL ending, alcohol. If this were an E, cyclohexane. I have a 6-membered ring. I'm going to put my hydrox group here. You could put it on any carbon. Most of you can do that. And then, oh, ethyl. Diethyl, that means 2 of them. What carbon are they on? Both of them are on the same one, 3. So I do this 1, 2, this is 3. How do I show diethyl? And this would be diethyl on 3, 3-diethyl cyclohexanol. Now, because it's the only functional group on the ring, we need no number 1 because everybody knows it's number 1, and therefore we don't have to do it. Now, listen carefully. Wednesday, I will be going over the alkenes, alkynes problem set. I highly recommend you do it before I do it. Also, if you have any questions while we're doing it, ask. Also, my office hour tonight and Wednesday night, ask. Don't forget the first lab is due. You go to the, I think it's called assignment area. I get my Blackboard and D2L mixed up names, and upload your file as either a single Word file or single PDF for the lab. Make sure you got your name on it or somewhere on there, and make sure you do it by Wednesday at the end of the day. And with that, I look at the clock and say, goodbye. Hopefully you had a fun day with Dr. White. You learned all about a lot of things, aromatic compounds, nanotubes, and alcohols. With that, I'll say goodbye. Gang gesund. Be healthy. I'll see you on Wednesday.